A 75 milliliter solution of hydrogen chloride with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molar calcium hydroxide. What was the concentration of the hydrogen chloride in the original solution? So first we're going to draw everything that we know from the problem. So we know that we have 75 milliliter solution of hydrogen chloride, but it has an unknown concentration. So that is equal to 0.075 liters, unknown concentration of hydrogen chloride, and since that's a strong acid, it'll break up completely. So we have H plus ions in there and Cl minus. And then it is titrated with 27.3 milliliters of 0.157 molar of calcium hydroxide. So since that's a strong base, it will also break up completely. So we have 0.0273 liters of a 0.157 molar concentration of calcium hydroxide. Okay, now that we've drawn what we know that we need to figure out the concentration of the hydrogen chloride. And so to figure out molar, we have to know the moles of the hydrogen chloride and divide it by the volume in liters. So what we don't know is how many moles of hydrogen chloride we have. And to be able to find that, we have to use the stoichiometry from the balanced equation to get from the moles of this to the moles of that. So to figure out the moles of this, it would be moles is equal to the volume times the concentration, just by rearranging the equation. So we have 0.0273 liters times 0.157 molar will give us the moles of calcium hydroxide. So 0.0273 times 0.157, that gives us 0.004286 moles. So to get from moles of this to moles of that, we have to use the stoichiometry from the balanced equation. So let's figure out what the equation is. So we know that we have to mix hydrogen chloride with calcium hydroxide, and that would give you water and calcium chloride. And since calcium has 2 plus, then we know that there will be 2 chlorides on this molecule. And then since we have 2 over here, then we have to have 2 over here. And then we have 2 hydrogens here and 2 hydrogens here, but there's only 2 on this side, so we have to make this 2, so it'll be a total of 4 on both sides. And then just to check, we have 2 oxygens and 2 oxygens. Okay, so we have the moles of the calcium hydroxide, and we need to get the moles of the hydrogen chloride. So we're going to divide this, and then by moles of calcium hydroxide, which is 1 mole of CaOH2, and then on the top you have 2 moles of hydrogen chloride. So whenever you work that out, it'll give you the moles. So we're gonna multiply that by 2, which would give you, so this equals 0.00857 moles. And then to get the concentration, we have to divide those moles by the volume, which we already have from up here, which is 0.075 liters. So 0.075 liters, and then that gives you 0.1143 molar. So that is the concentration of the hydrogen chloride. Some common mistakes people use would be to do the M1V1 equals M2V2 solution, but this would in fact give you the wrong equation, so that's wrong to do. And then another common mistake is mistakes made in the when trying to find out the balanced equation to get the stoichiometry, so always double check your answers with that. And